Hi, in this video I'm going to show you how to predict products of single displacement reactions. Sometimes they're called single replacement reactions. For this lesson you'll need your 5e notes and you'll also need a periodic table. So these reactions involve an element replacing another element in a compound. If the element is a metal, it's going to replace the cation in the compound. So here you see the basic form of a single displacement or single replacement reaction. There's an element plus a compound in the reactants, and you form a new element and a new compound as products. Here's a metal reacting with silver nitrate, and if this copper is more reactive than silver, it will replace it. Do you see how the two basically switch places? That's an example of a single displacement reaction. Now, if the element by itself is a nonmetal, it's going to replace the anion in the compound. Here we have chlorine, and it's going to replace bromine because it's more reactive than bromine. So the chlorine, a nonmetal, is replacing an anion, and you can see that they've switched places. Single replacement reactions only occur if the element that's by itself is more reactive than the element that's replacing in the compound. And to figure that out, you're going to need an activity series and an electronegativity series on the back of your periodic table. Here we've got an example of magnesium reacting with water. Notice how I wrote water as HOH. We're going to think of it as a hydrogen ion and a hydroxide ion. Now, we have to determine if magnesium is more reactive than this hydrogen here. So on the back of your periodic table, you should see this activity series. It's in the top right-hand corner. And here you see magnesium, and here you see hydrogen. These elements are listed in order from most reactive all the way down to least reactive. You know, think about it. Gold's a pretty non-reactive metal. That's why we can use it in jewelry. So because magnesium is in fact more reactive than hydrogen, the two are going to switch places. When we predict this product, you will write the hydrogen by itself, and because it's diatomic, we put a 2 there, and then the magnesium will replace it in this compound. So magnesium will combine with the hydroxide ion. Now magnesium has a charge of positive 2, and hydroxide has a charge of negative 1, so put parentheses around that and give that a 2. Then balance the equation by putting a 2 in front of the water, and that's it. If the solo element is a nonmetal, in other words, it's on the right-hand side of the periodic table, you're going to use this electronegativity series to see if it's going to be more reactive than the anion it will be replacing in a compound. So here we see bromine, and it will be replacing iodine potentially. If you look on this electronegativity series, you'll see that bromine is in fact more reactive of a nonmetal than iodine is. So this reaction will take place. So to predict it, you're going to kick the iodine out by itself. Now iodine is diatomic, so put a 2 there. And then you're going to write the compound created from a ammonium ion, NH4+, and a bromine ion, or anion, Br-1. So we don't really need any subscripts there. Now, to balance this equation, we'll need to put a 2 in front of the NH4Br and a 2 in front of the NH4I. It doesn't make any difference what order you write these products in. What does matter is that you write neutral compounds and that you only make this switch if in fact the element by itself is more reactive than the anion that it's replacing. If it wasn't more reactive, you would just write no reaction on the product side. I thought this was an interesting application of single displacement reactions that I found in this website called chemistryland.com, and it's where metals are used as sacrificial metals to prevent corrosion of other metals. So here in this example you see a picture of a water heater, and in a water heater you've got the water heater's tank is often made of iron. Well, iron in the presence of water and oxygen can corrode and form iron hydroxide. The iron atom loses electrons in that process. So what they'll do is they'll put a rod of magnesium or sometimes zinc inside the water tank, and what happens is, because magnesium is a more reactive metal than the iron, once that iron hydroxide forms, the magnesium will essentially replace the iron and donate its electrons back to the iron, and so the iron just becomes iron metal again, and that sort of prevents that whole corrosion process from occurring and keeps your water heater running for much longer than it would otherwise. So the key here in these single displacement or single replacement reactions is when a metal replaces another metal, it has to be more reactive than the metal in the original compound. And the most reactive metals are listed first in that activity series. Nonmetals will react by replacing anions in compounds, but they'll only do so if the nonmetal is higher up on the periodic table or if it's listed first in that electronegativity series. So that's it. I'm going to have you try the corresponding problems on the 5E Predicting Products worksheet. Best of luck. Just let me know if you have any questions.